Alright, so section 1.9 is problem solving with equations. So what we're going to do is we're going to take a look at some word problems that have equations involved, and they're going to be only in one variable for now. We'll take a look at two variable systems when we get onto that, when we look at topics of substitution and elimination later in the year. But for this lesson, we're going to take a look at problem solving that only has one variable. So let's take a look at the first example here. It says each of the base angles of an isosceles triangle has a measure that is 30 less than the measure of the vertex angle. Find the measure of each of these angles. So whenever you have an opportunity to do so, draw a diagram. So in this case, we have an isosceles triangle. We know that isosceles triangles have two legs that are the same. Traditionally, you draw these as your base angles, okay? And these are the legs that are the same length. So in this problem, we're told that the base angles are 30 degrees less than the vertex. So let's call the vertex x. So the base angle would just be x minus 30. Now for a problem like this, we have to remember our rule that the sum of the angles of a triangle equals 180 degrees. Again, the symbol here is sigma, it just means sum. I'm just putting it here so you get used to it, so when you get to calculus, you'll understand what that means. So let's take those three angles, add them up, set it equal to 180. Notice I really don't need the degrees on the 180 because I already used my variables without degrees, so if we'd like to, we can get rid of that. Okay, just so we have numbers, but our answer will be in degrees when we list the angle measurements. At this point in time, it's okay to drop the parentheses, simply because you really have a 1 here and you really have a 1 here. So it's like if you distributed these 1s to both, it would just drop off the parentheses. So really what we have is x plus x minus 30 plus x minus 30 equals 180. And now at this point in time, all we have to do is collect like terms and solve. So x equals 80 tells me that the vertex is 80, but the base angles must each be simply 50. Again, because the base angle was the same as the vertex, 80, but it's minus 30, which is 50. Check to make sure it makes sense. 50 plus 50 is 100, plus 80 is 180, giving us the sum of the angles of a triangle. Again, make sure you have your units given here. Example 2 says adults' tickets for the art museum cost $1.50 more than children's tickets. One day, 200 adults' tickets and 160 children's tickets were sold at the museum. The income from the adults' tickets was 30 less than twice the income from the children's. How much does each type of ticket cost? Well, we're asking about how much does each type of ticket cost. So we're looking at an adult ticket and a children's ticket. In the beginning, we're told that adult tickets are $1.50 more than children. So let's call X children's ticket cost. So since adult tickets are $1.50 more, we can technically say X plus 1.5 equals adult ticket cost. And this is per an individual ticket. Now, we're given a scenario. That's what we have to look at next. We're told that one day, 200 adult tickets and 160 children tickets were sold at the museum. So we have 200 adult tickets, and we have 160 children tickets. We're told that the income from the adult tickets was 30 less than twice the income from the children's. Well, the income from the adult would be the amount of tickets sold for adults, 200, times the cost per ticket. So that's going to be times the cost per ticket. That's the adult ticket income. And we're told that it's 30 less than twice the income from the children. So 30 less than twice the income from the children's tickets. And let's go over this one step at a time. Again, the income from adults' tickets, right here, means equal, 30 less than minus 30, twice the income from the children's. Twice, and this is the income from the children's tickets, because 160 tickets were sold at a rate of X dollars per ticket from our given statement. At this point in time, all we have to do is solve. Let's go ahead and distribute the 200. And 200 times 1.5 is simply 300. Now over here, be careful. There is no plus sign. So it's tempting to want to distribute this because you distribute it here. But there's no plus sign right here. So these are just multipliers. So multiply your common terms of 2 and 160 to give you 320. X minus 30. Add the 30 over to give you 330. Subtract the 200 to give you 120x. Now we can divide and take a look and see that x turns out to simply be $2.75 per ticket. So the children's cost per ticket is $2.75. Well, the adult cost is $1.50 more, it said. So if we add $1.50 to $2.75, we simply get $4.25 per adult. So those are the prices for each of the two different categories. Example 3 says, Bob, a city planner, has two pieces of metal wire of equal length. He shapes one of them into a square to represent a new building site, and the other into an isosceles triangle to represent a nearby park. The base of the isosceles triangle is 4 centimeters shorter than the side of the square. So right away we know we're going to compare the sides of the triangle to the square, so call the square x, because we're given what the triangle is in terms of the square. Since the base of the triangle is 4 less than the square side, we can call this x minus 4. And the leg of each, or in each leg of the triangle is 8 centimeters longer, so we can write x plus 9 and x plus 9. Now at this point in time it says how long was each piece of wire? Well, we know that the wires are identical, so the amount of wire that makes up the square is the same as the amount of wire that makes up the triangle. Well, the amount of wire is really the perimeter. So we could say the perimeter of the square is equal to the perimeter of the triangle. Well, the perimeter of the square is x plus x plus x plus x, or 4x. The perimeter of the triangle, we add the 3 x's together to get 3x, and we can combine the 9 and 9 to get 18. 18 minus 4 is 14. So this is our governing equation in this example. And what you'll notice is quite simple. When you subtract 3x on both sides, you simply get x equals 14. But we're not done. And that's not the actual answer, so I shouldn't even have boxed that in really, right? What we want to think about is the fact that we're trying to find the length of the wire. Well, the length of the wire is the perimeter of the rectangle, or the square, or the triangle. So since the perimeter of the square is easier, is listed as 4x, we could just multiply x times 4, and that will give us 56 centimeters. That's the perimeter of the square. Well, it's also the perimeter of the triangle. It happens to be the length of either of those pieces of wire, since they are indeed identical. So for the last example, a truck left New York at 2 p.m. for Queensbury, traveling at 40 kilometers an hour. Then at 3:15 p.m., a car left Queensbury, traveling to New York at 55 kilometers an hour. We're told that the truck and car passed each other exactly 2 hours after the car left Queensbury. How far is New York to Queensbury? So we have to think about this, and the easiest way to do these kinds of problems is to start by looking at a diagram. So I'm going to draw a diagram. I'm going to say, first, we've got the truck in New York, all right, and let's say this is Queensbury over here. The truck leaves New York and travels for a while, for about an hour and 15 minutes. And then as soon as it gets to this location, we'll call X for now, or just some spot in time, then we have the car leaving Queensbury, and we also have, again, the truck continuing its path. And these two are going to meet at some point along the way, okay, at another location at some point. So we know that this is traveling this way, but it starts at 3:15. So this has like a head start, okay? So if we could figure out the distance covered in the head start, then the distance covered for 2 hours for the truck, the distance covered in 2 hours for the actual car, then what we'll know here is we'll be able to find the total distance by adding those three distances together. So what we'll see is that an hour and 15 minutes, we need to think logically. 15 minutes is a quarter of an hour, so the time period undergone here is going to be 1.25 hours. Now, if 1.25 hours occur where the truck is going from New York on the way to Queensbury, we can find the distance traveled by looking at our formula D equals RT. So we start with D equals RT for this first portion of the trip. The rate at which it's traveling is 40 kilometers per hour, and it's traveling for 1.25 hours, and when multiplied that gives us a distance of 50 kilometers. So that tells us that this leg of the trip is 50 kilometers right here. Now we have to figure out these two parts next. Well, what we're told is that after 2 hours, they pass each other. Exactly 2 hours later. So it means that this time period right here is going to be 2 hours for this car to travel that far, truck to travel that far. And for the car to travel this far, which will be different, it's also 2 hours. Well, we know the rate at which they're traveling. The rate at which the car was traveling was 55 from Queensbury, and the truck was traveling at 40 kilometers an hour. So we have one of our distances so far. Let's find the other two. So for the truck now, for this portion of the trip, still traveling at 40 kilometers an hour, we have distance is 40 kilometers per hour times the time period of 2 hours. Well, that's 2 times 40, which is simply 80. So that means that that part of the trip is 80 kilometers. So that's this right here. Next, we then have to look at the car traveling from Queensbury in this direction, and it travels 2 hours before they meet up here. Well, 2 hours at a rate of 55 kilometers an hour means that it travels a total of 110 kilometers. So that's the distance on the third leg of the trip. Okay, 110 kilometers. So if I want to figure out how far it is from New York to Queensbury, I simply have to add together those three distances. So 1580 is going to give us 130. 130 and 110 will give us a total of 240 kilometers. So that is the final answer of the distance between the two by adding these three together right here. Your homework for this section is problems from 1-9. They're all word problems, and the 7 through 19 odd.